ሰላም ውድ የፋሲሌደስ ኢንተርናሽናል ዩቲዩብ ኦንላይን ትምህርት ተከታታዮች እንደምናችሁ እኔ መምህር የማታው ነኝ ዛሬ የምንማረው sum of arithmetic sequence ይሆናል ማለት ነው ይሄ ከ12ኛ ክፍል ሂሳብ ትምህርት ከአሁን በፊት ከተማርነው የቀጠለ ትምህርት ነው ስለዚህ ከአሁን በፊት ያየነው arithmetic sequence እና geometric sequence እንደውም ደግሞ summation of sigma notation የሚል በማየት ሞክረናል so ዛሬ ደግሞ arithmetic sequence special sequence እንዴት ሰምን እንፈልጋለን የሚለው ነገር ለማየት ሞክራለን so ለማየት we have to consider the sequence which is say for example 1 2 3 up to say let's say 100 Now, we wanted to take the summation of all these sequences so that we can say, in this case, this is the set of natural numbers starting from 1 up to 100. In this case, we have to do the arithmetic sequence with common difference d equals to 1, and the first term a1 equals to say 1, and also the last term a100, which is equals to 100. Now we want to show that what will be the summation of all this, which means the summation S100 is equals to የማለትም የነዚህ የካንድ እስከመቶ ያሉት ቁጥሮች ድምር ስንት ነው ተብለን ብንጠየቅ ለመስራት የሚያስችለን ስለዚህ 1 ሲደመር 2 ሲደመር 3 ሲደመር እስከ 100 ያሉትን መደመር ያስፈልገናል ማለት ነው በዚህም ጊዜ ይሄን ለመደመር S አሁን አዙረን ብናስቀምጣቸው ማለትም S100 summation of the first 100 natural numbers ብንጠራ ማለት ነው 100 plus 99 plus 98 plus up to 1 now if we take the summation of all this አሁን ሁለቱንም ብንደምራቸው ምናገኘው ምን ይሆናል So S100 plus S100 here ማለት ነው 2 times of S100 so meaning the sum of the first 100 natural numbers ማለታችን ነው ይሄን ሲደመረው ታዲያ 1 ሲደመር 100 101 ሲደመር 2 ሲደመር 99 101 ሲደመር 3 ሲደመር 98 101 ሲደመር up to 100 ሲደመር 1 101 ነው እናገኛለን ስለዚህ እንደምታዩት እዚህ ጋር 101 ሲደመር 101 ስንት 101 ይኖሩናል ማለት ነው ይሄ ማለት ታዲያ 2 times the sum of first 100 natural numbers equals to 100 times 101 times 101 ነው እናገኛለን ማለት ነው ስለዚህ over 2 ስናደርግ S100 equals to 100 times 101 over 2 ሆኖ እናገኛለን ማለት ነው so ይሄ ማለት S100 እኩል ነው ይሄ ሁለት በሁለት ይሄኛው አንድ ይሆናል በሁለት 50 ይሆናል 50 ሲባዛ 101 ሆኖ እናገኛለን የዚህን ብዜት ስታይቱኝ ስለዚህ 5050 ሆኖ እናገኛለን ማለት ነው Now, in general, if we take the sum Sn of first set of natural number 1 plus 2 plus 3 plus up to n now, እዚህ ጋር ያየነው እስከ 100 ያሉትን ለመደመር ነበር ነገር ግን in general n ብንለው ስለዚህ ምን ሆኖ እናገኘዋለን አሁንም አዙረን ብንደምረው Sn እኩል ነው S ስለዚህ n plus n minus 1 plus n minus 2 plus እስከ 1 ድረስ አዙረን ነው የደመርነው በተመሳሳይ መልኩ እዚህ ይሰራለው ማለታችን ነው ስለዚህ ማለት ስንደምረው Sn ሲደመር Sn 2 times of Sn which means Sn means the sum of the first set of natural numbers ስለዚህ አዙረን ሪቨርስ አድርገን የደመርነው እዚህ ጋር n ሲደመር 1 n plus 1 ይሆናል plus n minus 1 plus 2 ምን ይሆናል n plus 1 ይሆናል አሁንም n minus 2 plus 3 ማለትም n plus 1 ይሆናል plus plus as the last which is n plus 1 means which is n plus 1. So from this, how many n plus 1? We have n times of n plus 1. Therefore, Sn 2 times of Sn equals to which is n times of n plus 1 ነው እናገኛለን ማለት ነው። ስለዚህ ሁለት ሲባዛ the sum of the first n natural set of natural numbers equals to n times n plus 1 ከሆነ እችን ሁለትን ለማስወገድ both sides ሲካፈል ለሁለት ማድረግ እንችላለን። ስለዚህ ይሄ ማለት Sn እኩል ነው n over 2 into n plus 1 ብሎ እናገኛለን። እንግዲህ ይሄ ምን አገኘን ማለት ነው? the sum of the first n natural numbers. So the sum is calculated by simply n in essence the number of the sequences we wanted to add. So Sn equals to n over 2 times of n plus 1 ነው እናገኛለን። or በሌላ አነጋገር if we can take here in general if a1 plus a2 plus a3 plus out to an ብንወስደው እና እነዚህ a1 a2 a3 out to an ያሉትን የአርithmetic sequence ናቸው ብለን ብንወስድ እና arithmetic sequence ላይ first term አለው last term አለ common difference ይኖርናል። ስለዚህ በዚህ ይሄም እንደምታዩት እዚህ ጋር ያለው sequenceአችን arithmetic sequence ነበር common differenceአችን አንድ ሆነ ማለት ነው። ይሄን በምንደምርበት ሰዓት Sn equals to which is a1 plus a2 plus a3 plus an ሆኖ ካገኘ በዚህኛው ፎርም መሰረት Sn ማለት n over 2 into the first term we have a1 and the last term we have an which is ይችኛዋ a1 first term ነው ይሄኛው n ደግሞ an ይሆናል last term ማለት ነው። ስለዚህ a1 ሲደመር an ሆኖ እናገኛለን ማለት ነው። Now here we can calculate it in such a way. This also a formula for any arithmetic sequence with last term is an and the first term is a1. Number of terms is n. So Sn can be calculated by n over 2 into a1 plus an እናገኛለን። እንግዲህ arithmetic sequence ወይም ደግሞ arithmetic progression ቢሰጠን እና ድምሩን ብንጠየቅ በዚህ መልኩ መደመር እንደምንችል ነገር ግን የምታስታውሱ ከሆነ አሁን በፊት ስለ arithmetic sequence ስናወራ the nth general term of arithmetic sequence is calculated an equals to a1 plus n minus 1 times common difference d የሚል ፎርም ራይተን ነበረ። so ከan ቦታ in case an ባይሰጠን እና ኮመን ዲፈረንሱ ብቻ ቢሰጠን ከሆነ ከዚህኛው ፎርሙላ ይልቅ በዚህ በan ቦታ ይሄን ተክተን መስራት እንችላለን። ስለዚህ ስንተካው ይሄ an እኩል ነው the nth term, so the nth general term of an arithmetic progression or sequence is calculated here a1 plus n minus 1 times common difference d ብለን ስለነበረ በan ቦታ ስንተካው Sn እኩል ነው n over 2 into a1 አለን እዚህ ጋር a1 plus በan ቦታ a1 plus n minus 1 times common difference d ሆኖ እናገኛለን ማለት ነው። ስለዚህ a1 plus a1 ይሄ ማለት Sn እኩል ነው n over 2 into a1 plus a1 2 times of the first term a1 ማለታችን ነው plus n minus 1 times of d ሆኖ እናገኛለን ማለት ነው። ስለዚህ ይሄኛው ሌላኛው አማራጭ ፎርሙላችን ይሆናል ማለት ነው። ይሄም ራሱ the sum of the first n number of arithmetic sequences summation can be calculated by n over 2 times of a1 plus n minus 1 times d እናገኛለን። አለዛም ደግሞ Sn equal now n over 2 times of a1 plus an, the last term an ሆኖ እናገኛለን ማለት ነው። ስለዚህ ይሄኛው ሆነ ይሄኛው የተመቸኝና የተመስራት እንችላለን። እንደሚሰጠን የጥያቄ ወይም የምሳሌዎች አይነት የፕሮብሌሞች አይነት አይተን በየትኛው ፎርሙላ የተመቸ ነው የተሰጠን ጥያቄ በማለት መስራት ወይም ካልኩሌት ማድረግ በቀላሉ የአርithmetic ፕሮግሬሽን ወይም ደግሞ የአርithmetic ሲኩዌንስ ድምር በቀላሉ እንዴት መደመር እንደሚችል ያሳየናል ማለት ነው። አሁን ደግሞ እንዴት ምሳሌዎችን ፎርሙላዎችን እንዴት አድርገን የተለያዩ ምሳሌዎችን ለማየት እንሞክራለን። first example is that find S10 እንግዲህ S10 ማለት ምን ማለታችን ነው? ተማሪዎች ወይም ተመልካቾች ማስታወስ ያለባቸው S10 ማለት the sum of the first 10 terms ማለታችን ነው። so S10 if a part a1 which is equal to 5 and 18 which is equal to say 75. Now to solve this here class, you have to understand first what are given quantities and what is the required quantities. So we're asked to find the summation of the sum of the first 10 terms of the given sequence, with the first term is 5 and the last term, which is the 10th term, a10 is equal to say 75. So we must recall the formula Sn. So Sn is equal to as a solution here, solution. So Sn equals to, Sn is given by n over 2 into a1 plus an. We have also given this formula. So the sum of here S10, the sum of the first 10 terms of the given sequence, starting with first term is a1. So we have to n is say 10. So 10 over 2 into a1 is 5 given here plus an means a10. So we have to have here it is a10. The 10th term is 75. So we can simplify this. So this equals to 10 over 2 means 5 into 5 plus 75 becomes say 18. So the sum, the product 5 and 18 becomes say 400. So that given the sequence with the first term is a1, with the 10th term is 75. So the sum S10 is given by here 400. The first term is given 5 means here, which is the 10th term is given here 75. So the sum from a1 up to 18 is with the sequence starting from 5 is equal to say 400 የሚለውን ማየት እንችላለን ማለት ነው። Second problem, B part is say that a1 equals to 8 and the common difference D equals to minus 5. Here, as a solution, we can say the given quantity is with common difference. So the formula should be Sn equals to n over 2 into 2 times of a1 plus n minus 1 times of common difference D. We can calculate in such a way. Because since the common difference D is given and the n is given here also 10 and a1 is given. So instead of this formula, instead of Sn equal now n over 2 times of a1 plus an, this may be say preferable. So here we can say S10 is equals to 10 over 2, which is 10 over 2 into 2 times of a1 is given 8 plus n is given say 10 minus 1 times of common difference D is given, which is say negative 5, which is negative 5. So we have to have in such a way. From this, we can calculate this is equals to 5 into 2 times 8 is 16 plus 10 minus 1 is 9. 9 times of negative 5 here. So this can be simplified at 5 times 16 minus 45, because 9 times negative 5 is equal to negative 45. 5 is equal to 5 times negative 29. So from this 5 times negative 29, 5 times 9 is 45. We have 4, 5 times 2 is 10, 10 plus 4 is 14, so which is equals to negative 145. Now the third example is C part. C part is given by here, say for example, the sequence given 3, 5, 7, 9, and here it is 11 and extra, in such a way. From this sequence, as you see here, observe it, we are asked to find the sum of the first 10 terms of the sequences. The first term is 3, second term is 5 here. From this we can calculate it. D is equal to say 2, number 2. So the formula can be S10. Sn is equals to here n over 2 into 2 times of a1 plus n minus 1 times d. So from this we have S10 means S10 equals to 10 over 2. 10 over 2 into 2 times of the first term is 3, which is times of 3, plus n is 10, which is 10 minus 1 times of d. D is calculated already here, 2, so which is equal to say 2. Therefore, here this is equals to 5 into 3 times 2 is 6 plus 10 minus 1 is 9. 9 times 2 becomes say 18. So from this here, we calculated 5 times of 6 plus, which is 18 equals to say 24. Now 24 times 5 is exactly equals to 5 times 4 becomes 20. We have 2. 5 times 2 is 10 plus 2, which equals to 112. So our answer should be the sum of the first 10 term of the sequence, which is given by 3, 5, 7, 9, 11, extra, etc., which is an arithmetic sequence with the first term 3 and the common difference D is given by S10 is equals to 120 እናገኛለን ማለት ነው። ስለዚህ በሚመቻችሁ ፎርሙላ እንደምትሰጡት የጥያቄ አይነት አይዘር Sn equal now n over 2 into a1 plus an በሚለው ወይም ደግሞ Sn equal now n over 2 into 2 times of a1 plus n minus 1 times the common difference d በሚለው ፎርሙላ መስራት ትችላላችሁ ማለት ነው። ሌላ ምሳሌ ልጀምር። evaluate each of the following. A part, say for example, is summation of let's say 2n plus 5 when the value of n is equal to say from 3 up to say 20. From 3 up to 20. We can say like this. The summation of here 2n plus 5 when the value of n runs from n from 3 up to say 20. Here, as a solution, we can observe here. We can say n is an is calculated here 2n plus 5. If you start with n is set of natural number, so the sequence is given here. The first, if n is 1, we can say n is given here. N is 1. 2 times 1 is 2. If n is 2 plus 5. 2 plus 5 is exactly say 7. And if n is 2 times 2 is 4. 4 plus 5 is 9. if the value of n is 3, 2 times 3 is 6, 6 plus 5 is 11. So the sequence is given in such a way. With this sequence is, as you observe here, which is called arithmetic sequence or arithmetic progression, which the first term is 7 and the common difference d is, which is equal to 2. Now from this, to calculate S10, the value to evaluate summation of 2n plus 5, where the value of n runs from 3 up to 20. So we must calculate what is the value of n first. N is equals to the upper and the lower bound, which is 20 minus 3 plus 1, which is equal to 18 or 18. So the value of number of terms of the sequence is equal to 18. And also the first term is A1, the S3, when n is 3 becomes 11. So which is 2 times of 3 plus 5, which is equal to 11. And also A20. So A20 is equals to 2 times of 20 plus 5, which equals to 2 times 20 is 14. 14 plus 5 is 45. Now we are asked to find the summation. So summation of here it is 2 times of n plus 5, when the value of n runs from 3 up to 20 is exactly equals to here n over 2 into A1 plus, which is A20. So which is equal to, an plus A1, the first term is A1 and the last term is an. But instead of A1 we have to have A3 is equal to 11. So n is 18 here, so which is equal to 18 over 2 into A1 is here, it is instead of A1, which is A3, which is equals to 11, plus it is equals to an is 20 is equal to 45. So from this we get 18 over 2 is 9 times of 11 plus 45 becomes when you take the summation of 11 plus 45, the result becomes 56. Now when we multiply 9 by 56, which equals to 9 times 6 is 54, we have 5, and 9 times 5 is 45 plus 5 is 15, so your answer should be 504 So እዚህ ጋር ዋናው መያዝ ያለባችሁ ጭብጥ summation of, you have to evaluate summation of 10 plus 5 when the value of n runs from 3 up to 20 ስንባል you have to observe that the sequence is n equals to n plus 5, which is an arithmetic sequence with common difference 2 and first term is 7. So we first calculate the value of n, which is the difference between the upper and the lower bound. When you count, which is first term is instead of 3, and the last term is instead of 20. So we have 20 minus 3 plus 1, which is 18. Meaning the number of terms we are going to take the summation is A1 plus A2 plus A3. An becomes which is n is 18. So A3 when n is 3, which is 11. A20 when n is 20, 2 times 20 is equal plus 5 is 45. So here, after this, you can use the formula, and Sn equals to this S summation means this summation which is equal, but in other words, S 18 ብሎ ሆኖ እናገኛለን ማለት ነው። So the result becomes 504 እናገኛለን ማለት ነው። Example is, say, evaluate the summation of 3n minus 2 when the value of n runs from 2 up to 25. Now to evaluate this as a solution, ይሄን ለመስራት እንግዲህ የሚያስፈልጉን ነገሮች መጀመሪያ ማየት ይጠበቅብናል። ስለዚህ n ራሱ ስንት ነው? So n which equals to say 25 minus 2 plus 1. So the result which equals to say 23 plus 1 is 24. So the number of terms of the sequence we will going to add is 24. And the general term of the sequence is 2n equals to say 3n minus 2. 3n minus 2. Now from this part, if n is 1, the first term is 3 times 2 becomes say minus 1. If n is 2, if the value of n is 2, 3 times, positive 1. If n is 2 here, 3 times 2 is 6 minus 2, which is equal to say 4. If n is 3 times 3 is 9. 9 minus 2 becomes 7. So this is an arithmetic sequence with common difference. Common difference is when you take the difference, 4 minus 1 is 3, 7 minus 4 is 3, and the next part will be at 3, so the common difference is equal to 3. Now, what is A25? A25 is calculated, which is equal to 3 times of 25 minus 2. The result becomes 3 times 25 is 75 minus 2 is equal to 73. Therefore, as this summation of which is 2 times 3n minus 2, when the value of n runs from 2 up to 25 is exactly equals to n over 2. N is given here, n is equal to 24. So 24 over 2 into the first term, n is 2, when n is 2, so which is equal to 2 minus n is 2, which is 4. So plus, and A25 is equal to 73. So from this part, which equals to 12 times 24, simplify here, which is equal to 12 times of here, 4 times 73 is equal to 77. So the product is, when we multiply with 12 times of which is 77, the result is equal to 924. The fourth example says in arithmetic progression or arithmetic sequence with A4 or the fourth term, what you call, which is A4 is equal to 84 and A10 is equal to 60. So find the maximum possible partial sum of the sequence. Given an arithmetic sequence here, with the fourth term A4 is equal to 84, and the 10th term is here, which is equal to 60. So what will be the maximum possible partial sum of the given sequence here? Now, this problem is a little bit different that's what I've done before. Therefore here, we have to have A4 is given and A10 is also given. So here, as a solution, we must calculate A4. A4 is equal to 84. We have to recall the formula that AN equals to here, which is A1 plus N minus 1, which is N here, the value of N is 4, which is 4 minus 1 times D, which is equals to 84. And again, A10 is given, so which is equal to 60. From this, we can say here, which is A4. So we can calculate it here. Calculated A1 plus the N is 4 minus 1 times D, which equals to the fourth term. So and again, so since the 10th term is calculated here, A1 plus the 10th term is 10 minus 1 times D, which is equal to 60, which is equal to 16. So we can say, since given the fourth term is 84 and the 10th term is say 16. So first we must calculate the value of A1 and the value of common difference D here. So when you subtract here, here A1 minus A1 is cancelled out, and again 4 minus 1 is 3D here, 3D, and again 10 minus 1 is 9D. So the result is here 3D minus 9D equals to say minus 6D. Minus 6D equals to say 84 minus 60 is equals to say when 4 minus here it is equal to 24. Now from this we can calculate minus 6 times D over minus 6 equals to 24 over minus 6. Therefore, the value of D equals to 24 divided by minus 6 equals to, which equals to D is exactly equals to negative 4. D4 በዚህ መልኩ አገኘን with D equals to negative 4 የሚለውን ካገኘን በኋላ ከነዚህ ከሁለቱ ኢኩዌሽኖች አንዱ let's say star 1 and star 2 ብንላቸው ከሁለቱ አንዱ ነው ስጄ A1 ወይም የመጀመሪያ ተርምን ማግኘት እችላለሁ። ስለዚህ አንደኛውን ቦታ ለምሳሌ A1 plus 3D equals to 84 የሚለውን ብንወስድ once calculated already, it is D, and now we must calculate the first term A1. So A1 plus 3 times D which equals to negative 4, which equals to 84. So A1 plus, which is 3 times minus 4 becomes negative 10, so which is equal to say 84. So A1 first term, ይሄን ወደ ታች እናስቸግረው ስለዚህ ፖዚቲቭ so which is equal to 84 plus 12 እናገኛለን ማለት ነው። በመጨረሻ የመጀመሪያው ተርም A1 equals to 96 ነው እናገኛለን ማለት ነው። አሁን እንደምታዩት እዚህ ጋር 96 የመጀመሪያው ተርም ከሆነ D ደግሞ negative 4 ከሆነ so first term is 96, the next part will be decreased by negative 4, so 96 minus 4 becomes 92 ነው እናገኘዋለን. And again 92 minus 4 becomes which is 88 and the third term 88 minus 4 becomes which is 84 እያለ ይቀጥላል። እንደምታዩት ይሄ arithmetic sequence arithmetic ነው of course with common difference equals to negative 4, so it is decreasing. That's why the problem is we're asked to find maximize the sum. So the fourth term is equal to here 84, which is the fourth term is equal to 84. Now here, what will be the general term AN? Recall AN equals to A1 plus N minus 1 times D. So from this, AN is exactly equals to A1 is 96 plus N minus 1 times D. N minus 1 times common difference is negative 4. So when you multiply here, 96 plus minus 4 times minus 1, which is minus 4n plus 4. So which equals to 96. 96 plus 4 equals to, which equals to say 100 minus 4n. This is side AN. So here the nth terms of this sequence is as a general formula is equal to 100 minus 4n. Now to become our problem, to maximize the solution, I mean the summation, which is a partial sum, to maximize the sum, our sum, we must take only positive terms. Positive terms. That means which is AN should be greater than or equal to what? 0. So this implies that this AN is already calculated here, which is 100 minus 4n should be greater or equal to 0. When we calculate it here, which is 100 should be greater or equal to say 4n. So this implies that over 4 we have 25 should be greater or equals to say 4, n. Meaning that this implies n should be less or equal to say 25. Therefore here, since or equals to, the value of n equals to say 25. Now, so we must, to maximize the summation, the number of terms of the sequence is equal to say 25. Therefore, our formula is Sn, which is equals to Sn is exactly equals to, or S25. We can say S25. 25 is exactly equals to, which is 25 over 2 into 2 times of A1, or the first term is say 96, and the last term is if n is 25. If n is 25 here, 25 times 4 is say 400. So 100 minus 100 is say 0. So the last term is say 0. So we can take in such a way. So our result is equal to say 25 times 96 over 2. So when you simplify here by 2, 1 by 2 is equal to 48, which is equal to 25 times say 48. So your final result is, when you multiply 25 times say 48, the result is 1,200. So our maximum sum becomes 1,200. እናገኛለን ማለት ነው። እንግዲህ እዚህ ፕሮብለም ላይ እንደምታዩት ምንድነው ለማየት የተሞከረው to maximize the summation and then determine ማድረግ ይጠበቅብናል ማለት ነው። እንዲሁም ደግሞ የኮመን ዲፈረንሱን አብሮ ማያያዝ እና ማየት ይጠበቅብናል ማለት ነው። The example for our today's lesson is that if the n's partial sum of an arithmetic progression and arithmetic progression or sequence is given by which is equals to say n squared plus 3n. Then find the formula of the nth general term an. So here, as I was saying before, the sum Sn and the general term an is not interrelated. Rather, this is the nth partial sum, and this is simply the nth general term. So, given the partial sum of the sequence in the formula Sn, which equals to n squared plus n, and we are going to find the general formula for what an. So, እንደዚህ አይነት ጥያቄዎች ሰጡ እንግዲህ ምንድነው የሚጠበቅብን የተሰጠውና የተፈለገውን ለይቶ በማውጣት መጀመሪያ የተሰጠው ምንድነው Sn ነው። Sn ማለት እንግዲህ ታስታውሱ ከሆነ Sn which equals to a1 plus a2 plus an ነው ብለናል። So በዚህ ላይ Sn ተሰጥቶናል። Sn equals to which equals to n squared plus 3n ነው። Now we are asked to find which is an ነው። an ስንት ነው ተብሎ ነው የተጠየቀው። So ይሄን ለማየት ምንድነው ማለት? So which is equals to here an is exactly equals to Sn minus 1. Look, we can observe here. An equals to Sn minus 1. ለምንድነው Sn minus 1 ነው? Look, Sn ማለት a1 up to an ነው። Sn minus 1 ማለት ደግሞ the sum which is Sn minus 1 is exactly equals to, it is a1 plus a2 plus out to what an minus 1 ይሆናል ማለት ነው። ሶ እቺኛው ኤ የለችንም ማለት ነው ሶ ሁለቱ ልዩነት ስናቸው a1 sn minus sn minus 1 ማለት an so a1 with a1 a2 with a2 a3 so every term should be cancelled out by itself except which is an so that sn equals to an equals to sn minus 1 million እናገኛለን so this is exactly equals to sn is given here n squared plus 3n which is n squared plus 3n now minus what will be sn so sn is here sn minus 1 is exactly equals to here n minus 1 the whole square plus 3 times of n minus 1 እናገኛለን ማለት ነው so which is n into n minus 1 the whole square plus 3 times n minus 1 እናገኛለን ማለት ነው so this is exactly equals to n squared plus 3n minus here we have n square of n minus 1 the whole square means which is binomial formula so n square minus 2n plus 1 እናገኛለን and again 3 into n minus 1 means 3n minus 3 እናገኛለን ማለት ነው so when we simplify so n square plus 3n minus here n square minus here it is minus 2n plus 3n becomes plus n and again 1 plus negative 3 becomes minus 2 so we have that so this the negative side inside the bracket becomes here n square plus 3n minus here n square and again here plus minus n plus 2 so that here n square with n square is cancelled out and again 3n minus n becomes 2n which is 2n and again here it is the number 2 so that given the nth partial sum of the sequence Sn is given by n squared plus 3n so the general term an the nth general term of this arithmetic sequence is given by an which equals to 2n plus 2 ነው እናገኛለን ማለት ነው ተመልካቾቻችን የዛሬው ክላሳችን በዚህ ያበቃል ማለት ነው በሚቀጥለው ክላሳችን ደግሞ የጂኦሜትሪክ ሲኩዌንስን ሰም እንዴት እንደሆነ እናያለን ማለት ነው እስከዛው ሰላም